Okay, in this example we're going to use a linear relationship model. We're going to model the cost of putting on a concert for preschool. Now the cost is going to depend on setting up, which is $80, and $3 per kid. Now, N is the number of kids and C is the cost. So we're going to graph this function like we're asked to. We need to first of all set up a table and choose some values for the number of kids coming. So let's, typical concert might go from 0 up to 200 or maybe a bit more, and work out the cost for each number of kid coming. So if no kids come, so it's still going to cost $80. So when N is 0, C is 80. If 50 kids come to the concert, 50 students, then it's going to cost 3 lots of 50, 150, plus 80 is $230. So that's a point there. If 100 kids come, that's 3 times 100, 300, plus 80 is the cost is 380. If 150 kids come, 3 lots of 150, 450, 530. And if 200 kids come, that's 3 times 200, 600 plus 80. So there's our table of values. I go down to, we get a graph now, and when we label our axes, the bottom we put down here is what we call the independent variable, the number of kids coming, and up the y-axis we call that cost. We call that the dependent variable because the cost depends on how many kids are going to come. So now we can start plotting these points off. So if 0 kids come, it's still going to cost us $80. So we put in, I might change the colour there to something like yellow. So okay, so 50. That's the first point there. Now if 50 kids come, then the cost is 230. So we're up to 230 there. If 100 kids come, that's 380. If 150 kids come, that's 530. There. 200 kids come, it's 680. You'll notice that they're all on a straight line. Just change the colour of that straight line to yellow. Put my graph through them. Okay. And what this means now is that I can go further along the graph and extrapolate it and work out the cost. If 50 kids come, just go up to the graph and onto the axis. So there you go. I have done a graph of the function for the cost of setting up a concert.